sequence start. 6, 5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff.
Welcome to the Obscast, the podcast dedicated to Sherwood Observatory and soon-to-be Planetarium, its members, visitors and all budding astronomers. This episode we are talking about the possible implications of long-term space travel on the people who may one day embark on such voyages to the Moon, Mars, maybe even other planets in our solar system, and one day maybe beyond, further into the cosmos. My name is Joe Gathercole, and here as well for this episode are Kathryn Wass, our designated long-term space travel correspondent for today. Steve Smith is of course here, Tony Booth is here. They're both here to join in the conversation with, I'm sure, some insightful thoughts and questions. And Steve will also have his fantastically detailed guide to the night sky throughout June later on. Guys, thank you very much for being here.
Thank you.
Thank you.
We were also meant to be joined by Michael tonight to discuss SpaceX and Starship's own ambitions for long-distance space travel. Unfortunately, he's not well, so we wish him a speedy recovery, and I'm sure we'll catch up with him after the next launch attempt anyway.
We do, yeah.
But for today, Kathryn, not only did you choose this topic, because it's a great topic, by the way, but you have also done some research on it. So what did you find out about side effects, challenges, and maybe outcomes, either good or bad, of being on a spacecraft for longer periods of time?
Right. With so much in the news these days about lunar exploration efforts, it really does feel like the space race is back on. I've always been interested in human behaviour and psychology, and after watching a documentary on the Space Shuttle Columbia, where in 2003 all 7 crew members sadly died, it made me think about the impact on astronauts and their families for lengthy space travel. It's thought-provoking to imagine just what it would be like to leave on a lengthy space travel, to spend long periods of time in space or even to travel to Mars. Embarking on such mission involves meticulous astronaut selection, emphasising qualities such as teamwork, effective communication, and the ability to live harmoniously in a small group. As advancements in space technology pave the way for extended missions, both manned and unmanned, it becomes imperative to understand the physical and psychological impacts on astronauts and the potential opportunities that arise from such endeavours. So we'll think about starting with the physical challenges. Prolonged separation from Earth poses numerous physical challenges for astronauts. Microgravity, cosmic radiation, and the harsh environment of space can lead to detrimental effects on the human body. Muscular atrophy, bone density loss, and cardiovascular issues are among the primary concerns. Scientists and engineers are actively working on developing countermeasures, such as exercise regimes, protective shielding, specialised diets and food supplements, plus medical monitoring to mitigate these risks and ensure the well-being of astronauts during extended missions. We were basically not really designed to be in without gravity, are we really?
No, it's a little bit different to what we're used to, isn't it?
It certainly is. It certainly is, yes. So there's all sorts of challenges really that we face.
And including the takeoff.
Absolutely, yeah.
Yeah, and the acceleration and G-forces, and there's a lot of things can go wrong. So,
You'll have the similar, or possibly similar G-forces and slow it down at the other end.
yeah.
Yeah.
So you could spend a long time in microgravity floating around and then have to buckle in for quite a high G burn to slow down again, maybe.
Yes.
Yeah, because the microgravity, that has a lot of negative effects on the body as well, doesn't it?
Yeah, it certainly does. There's all sorts of things. I mean,
If you're not accelerating, even if you're travelling at speed, then you're messing your heart and your vascular system, cardiovascular system, your blood and everything. Gravity is not affecting your system, is it?
No.
So it's a bit weird, and parts of your body, your face swells up and all sorts of things, really. It's weird.
Yeah, it's
is
used to
weird.
being pushed down to your legs and your feet where you hold a lot of it, and then it's not happening anymore, is it? I know currently on the space station they've got a specialised piece of equipment called Advanced Resistive Exercise Device, which uses cylinders of air to provide resistance for weight training.
Oh, I saw that.
And there's still that muscle atrophy you mentioned earlier on, even when they're using that and come back. And this machine can be utilised for various exercise, and it's still not enough. But I've seen videos of this machine, and it's big and clunky.
Yeah.
So you've got to think how, if you're lifting up a lot of weight, you want to save weight wherever you can.
Yes.
Obviously, for International Space Station, you think, well, we get that up there in one thing and it's up there for as long as we need it. But if you're building something that's going to go further and further and you're hoping to keep doing launches, say to the moon.
Yeah, yeah.
Your muscles atrophy in time and over a long period of time, like if you're on the International Space Station, they atrophy even more. But you still, and you may be weightless. And everything else alongside you may be weightless. But if you try and move an object, you still need to apply a certain force to that mass to get it moving. The bigger it is, the more massive it is, the more force you have to give it. So you need muscles still to pull yourself around, to get up. So, yeah.
When I was watching them do I was watching the SpaceX program and they were doing a spacewalk and how exhausting it was for them. Because not only they got the suit on and everything else as well, it's just that everything's very different with you using your muscles.
And this machine helps with that because obviously you can't lift weights. Well, you can lift weights really easily in space. Actually, you just and it's a lot easier. That's why they have these cylinders, and it kind of bent on an axis, and you were pushing against the cylinders.
Oh, that's clever.
That were filled with air. So there's always that resistance, and it was Scott Kelly, or I'll mention in a minute actually. I saw him doing a video and showing this, and he said it's so well built it feels like just lifting weights on Earth.
Brilliant. That's
and
clever.
He was doing squats.
Yeah, because obviously Joe alluded to like the fluids in the body, and also what happens in microgravity is that the fluids tend to shift upwards into the head, which causes sort of pressure on the eyes, and they report a lot of eye problems when they come back. So one of the things they do to alleviate it is that they use compression cuffs on the thighs, and that helps to keep the blood in the lower extremities. And with a lower negative pressure, that can help draw excess fluid from the head into the extremities and into the legs.
Yeah. Do they suffer with headaches? I suppose they must do, really, with that pressure in the face.
Fluid
retention.
Fluid
in the eyes.
Yeah, that was something from Scott Kelly. And Scott Kelly he spent a year in space, the longest stay in space. He was on the ISS for a year. And so they collected loads of data on him, and he's got a twin brother, whose first name I've forgotten. They had the same test on at all times, with one of them in a NASA facility on Earth, and one of them at the space station. And some of the differences were bone density, because you're not working out and using gravity to keep your bones going, so you lose what you don't use in space, muscle mass and bone density. But one of them was Scott Kelly's eyes. He had a problem, and I don't think it was, if I remember correctly, it wasn't something that just went away to coming back to Earth. I don't know if it was permanent. I can't remember what it was, but it caused issues that are them thinking, well, how are we going to deal with this on a longer trip to Mars? Because you need to be able to see what you're doing when you get there.
You do.
It helps.
For a whole year. That's a great comparison, having a twin, isn't it? Really good control there. Yeah.
And it takes 9 months to get to Mars.
Yes.
That's one way. And he was there for a year. And so that's not including, say, it's 18 months just getting there and back.
Yeah.
And you've got to wait 2 years, is it, Steve, to come back? So you're, 3.5 years minimum.
Because the Earth and Mars are travelling around the sun at different rates. So at some point, the Earth can be 93 million miles away from the sun and 93, even further away from Mars. It's only when they coming closer together again. Yeah.
I mean, that's another thing about sort of long-term space flight, because NASA did a study and they found that any crew members returning after being out there for sort of 12 months or longer, they had problems with their cognitive performance for up to 6 months after getting back home.
Oh, gosh. Yeah.
See, that's
it's not all fun and glory.
No. But if you get there and you're not
can't
cognitively
see
functioning,
and you can't think, and you
can't stand up on Mars. Even Mars gravity might be difficult after spending that time in, just standing. Because when they get back to Earth, they have help. There's people there waiting for them. When you get to Mars, there's no one waiting for you to get you out the couch.
Imagine just
they'll
crawling
walk
out.
you over to somewhere where someone's got a meal prepared.
Yes. Not quite the entrance we were expecting to meet if we were meeting aliens from other planets.
Yeah, and if there is something there greeting you and getting you out of the capsule, you've got bigger problems than not being able to walk very well.
That's right, yes.
Yeah, it'd be interesting to know how much deterioration may involve just going to Mars. If it takes 6 months, say, to get there. It's not like being in space for a year and getting there. If you're going any further, if you're going to Io or another moon eventually, we've got the same problem again, only more so. So, and you've got the psychological side of things.
Well, they're more isolated, aren't they? They're more further away from home.
Communication's difficult as well, because it takes a long time for light to get from Mars to us, depending where we are in our orbit as well. 20 minutes or whatever. So
that's going to
very,
contribute
very
to
difficult.
Mental challenges, isn't it?
So isolation, confinement, and the psychological toll of being far away from Earth are really big, significant aspects that cannot be ignored. The confined interior of spacecraft and the vast emptiness of space can induce feelings of loneliness and stress. Maintaining mental health during prolonged separation is crucial for the success of the mission. So psychologists and space agencies are exploring ways to provide adequate support, including virtual communication with loved ones, collaborative projects, entertainment options, and psychological training to help them cope with the challenges of isolation. So, recognising the limitations of current communication methods for deep space travel, scientists are looking at innovative remedies for isolation, highlighting the importance of astronauts feeling heard, understood and connected to a social network and their family. So virtual reality emerged as a potential solution, and space station astronauts will soon be able to enter virtual reality to help stay mentally healthy away from their home planet. Astronauts can now get a bit of simulated fresh air while working out in space, as we've mentioned the exercises. So they're working on this VR headset paired with a new exercise bike. It lets the astronauts experience their favourite cycle routes on Earth, which must be quite nice. And astronauts speak with a psychologist once every 2 weeks. They have scheduled rest times, regular calls with family and friends, and encouragement to pursue hobbies whilst in orbit. So the challenges of confinement, where astronauts spend months in close quarters, emphasise the need for individuals who can maintain functional team and family dynamics. And maintaining positive relationships and providing astronauts with someone to talk to outside the crew are essential for preserving sanity. I was particularly interested to read about, I call it Simon, so it's CIMON 2, I think there was a version 1, and Simon stands for Crew Interactive Mobile Companion. And it's a spherical AI-powered assistant to support and increase the efficiency of an astronaut's work. But it further explores the potential of artificial intelligence in mitigating isolation effects. It was designed to aid astronauts above the ISS space station with various tasks and provide emotional support during long-duration missions. So if you kind of think of Wilson in the Tom Hanks film Castaway, and whilst only fiction, the volleyball is a representation of the human need for companionship, connection and coping mechanisms in isolation. We could talk about that a little bit later on. It's really interesting. And so technological advances. So the need for prolonged space missions has driven innovation in space technology. Autonomous systems, advanced life support systems and sustainable resource management are key areas of research. Developing technologies that can function reliably for extended periods is essential for the success of missions beyond Earth's orbit. This push for innovation in space technology not only benefits space exploration, but also contributes to advancements in various fields on Earth. So, as astronauts return home, the transition process becomes a critical aspect. Helping them reconnect, cope with potential changes, and readjusting to Earth's environment requires careful consideration, especially after extended periods of isolation. In conclusion, long-term space missions necessitate a comprehensive understanding of both the physical and psychological challenges for humans. Ongoing research is essential to ensure the well-being and success of future space travellers who don't want to end up feeling lost both in space and when back on Earth.
Can I ask a question?
You can.
Why do we need to send a human to Mars? Why are we doing it? Is it political? Is it so we can have the first human being on another planet? Or is it because we need that human involvement when he gets to a planet so they can see things a robot can't do?
I can think of
Do you think
two
it might
reasons.
be political or...?
One is shorter term. It's easier to do science with a human that can see things a robot can't see. It can identify things a robot can't identify. It's got dexterity, and you can think on the spot rather than a programmed algorithm, maybe. So if you can get them there in a lab and keep them alive,
Well,
they can do a lot of really good science, more than the robots could, because even the tools that are on the robot are miniaturized versions of things we can make bigger and better in a lab. I think that my second thought would be just not having all your eggs in one basket in the terms of the future of the human race.
yes. Yeah. I think I was, say again, watching this programme about Elon Musk and his Starship, and he just wants to he's currently developing a fully reusable launch system. Is that Starship? Is that what it is? With the goal of going to the moon and creating colonies on Mars. So, it's a big...
Yeah.
It's a big romantic thing, really, isn't it?
It is really.
We, as humans, we've travelled all over the globe. We're travelling deep underwater. We're now going out into space. And we just love to explore. It's in our nature. And I get that. And I think it'd be fantastic to see the first human beings on Mars and elsewhere in the solar system.
There is, as you say, always a political side to it, though.
Oh yeah, like you said, there's always something.
The space
political.
race was a political thing.
Yeah. It's about our nation wants to get there first. It's how it is. But obviously, the other thing is there's no humanoid robot advanced enough yet to do what we can do. Although one of the things, and this is looking into the far future, Elon Musk again, he's developing this Neuralink thing, which is basically six microchip in your brain. And one of the ideas I've heard is they'll be able to send sort of robots to Mars, but you would be linked to them by Neuralink, so you'll see what they see. You'll be able to control them.
Interesting.
Basically, same as if you were there.
Wow.
But that
sounds a bit horrific.
Yeah.
That's a bit scary.
Yeah.
And that comes with its own mental challenges.
Yeah. Yes, it is. That the whole sort of governance thing worries me as well. It's.
So you were mentioning the mental challenges.
Yes.
Of getting there,
getting
back, and staying there.
Yeah.
And it made me think that, like on the ISS, no matter how long you're up there for, you can get back, you can get help, and it's a lot shorter journey than if you're on a long trip out. So Scott Kelly's year in space for a long time, but it's shorter than a lot of journeys will be in the future, and he had Earth right there, a few minutes re-entry away. If someone on the ISS needs any mental or physical attention for any reason, and it gets bad enough, they can come home.
Well, that's true.
You can't once you've used your fuel up to set off and go.
No.
And that probably plays a role in mental health, knowing that there's a point of no return on every mission, isn't there?
Yes, it must be. It must be. And they've sacrificed a lot. These are highly performing individuals that at the peak of everything, really, and they go off and they're committed to doing what they're doing. And you've only really something's got to go wrong, and like you were saying about the distance in the time for communication, it's almost instantaneous at the moment, but the further and further they go, and you're waiting 5 minutes, and what if there was a break in communications, and or things like, what if they'd had some bad news back on Earth, would you tell them whilst they're out there travelling? And
Yeah, because those astronaut candidates, they must go through some really rigorous psychological and as well as physical testing, before they're even considered for training.
Yeah, they must have to. And I think as a parent, I found it fascinating as well, particularly listening to some of the interviews that they had. And so, I think he was ex-Marine, jet pilot and everything like that. And so professional in everything. And then I think he was all prepared. They were ready to go off. And they had to abort the mission because of the weather. And he'd already said goodbye to his 7-year-old son and everything. And of course, obviously, they stopped and they had to go another day. But apparently that little boy, he wanted to go and sit in, he couldn't really talk to his mum. I think he'd psyched himself up for his dad going. And I think at one point, he might have said something like, "I don't really want you to go." And you could see his face. So it overrides everything, that emotional.
There's a whole other aspect of the psychological side of it. Yeah.
They're very complicated.
Yeah. I mean, with that distance in communication time increasing, because you mentioned they speak to a psychologist on the ISS every 2 weeks.
Yes. Yeah.
And that's something I've never considered, but now you say it, it seems so obvious that, of course, they're doing that all the time because it makes sense. But that's going to be a lot harder from somewhere such as Mars, or getting closer to Mars or further away, because it's a one-way signal can take about 20 minutes to get to Mars and then get back. So that's not a proper conversation.
No.
You sometimes, if you're having a moment, you probably want to get in touch with them right now, and then it's going to make simple conversations more jarring, more difficult, and it's not a huge delay, but compared to what they can do on the ISS,
that's an age.
Yeah.
It's an absolute age, isn't it?
So
And you haven't got the support system either, have you? Medical support.
No. But what I can gather from Simon, which I really absolutely loved him, is it's not really good for the listeners, but this is what Simon looks like. Basically a ball with eyes, nose and a mouth.
Kathryn showing us a picture of something that you would never get me alone in a room with. It might look nice, but that's a sly smile.
That's what it looks like.
It's a bit, yeah.
Yeah. But apparently, this obviously, I'm not an expert. This is from what I gathered. So obviously, it's got artificial intelligence. And so obviously, astronauts are not really going to give a lot away to NASA or, mission control. They're not going to say, I'm feeling really grim. They will be holding all of these sort of thoughts in them. So I think the idea was that, you'd sort of, Simon, it would be, good morning, Kathryn, how are you? And I'd say, well, actually, Simon, I'm feeling a bit low today. And it would say, well, could you explain what in particular are you feeling low about? Well, I'm missing my friends and my family. And it would say sort of like, well, we've discussed this before you left. There's been provision for the family. So it would almost be reactive AI. Equally, it would be, I've had a great day today. Oh, that's fantastic. Tell me about it. Just somebody to bounce off, because we all need somebody to offload to, don't we, really? And probably, a good percentage of feeling a bit down can be mitigated by just sharing it with somebody else, because you're with your crew members all of the time. You probably don't want to speak to them that much.
They're probably the problem.
Well, they probably are the problem, yes.
I had two thoughts when you mentioned AI. One of them was Hal from A Space Odyssey.
Exactly.
And the other one was a little paperclip popping up in the corner of the screen saying, looks like you're having a crisis in space. Would you like some help?
That's a blast from the past, yes.
I mean, one of the other things as well I've read about is, particularly on the ISS, is this circadian rhythm, which is like your body clock, your 24-hour body clock, because obviously, from prehistoric times, we've lived to this 24-hour cycle, sunrise, sunset. We know when to go to sleep, we know when supposed to get up. ISS, it orbits Earth every 90 minutes. That's 16 sunrises and 16 sunsets. So getting a decent bout of sleep is very difficult. It is. So I think what NASA's done, they've developed specialised lighting, LED lighting. And that's supposed to help them sleep properly, because obviously they need to be alert. Yeah. They need to be awake, because they have a hell of a job to do. Yes. They need to be concentrating solidly for hours at a time. They can't be up half asleep when they're doing that. So, yeah, there's so many things that they're faced with that I'd not even really thought about.
No.
So does that lighting kind of come up naturally at
Yes.
fake dawn and then go back down at fake dusk?
Yes.
To put rain on the windows and clouds
yeah.
and stuff as well, and make it seem normal.
Yeah.
Have like a cockle in the morning and stuff.
Yeah.
Yeah. I found
Someone with a lawnmower.
It looks like it's a lovely day today.
Yeah, good night, John boy.
they did that with this is Colombian mining disaster. I remember watching that, and they did actually get some. They did reference NASA for some expertise on that, because it was a very similar situation where the miners were trapped underground and the family was above ground, obviously, and obviously, communication was the main thing. As soon as they could get them to communicate with each other, that was great. They could tell their loved ones that they were fine. And they tried to replicate a lot of what you've just spoken about. They created today it's light now, and you should be awake, and it's dark and you could go to sleep. So they to try and bring people into a rhythm, even though they were trapped underground in an unusual
Yeah, it still must be
circumstances.
difficult.
Yes.
In the dark all the time. I mean, on a space station, not in the end, like vertical sleeping bags,
Yeah.
kind of strapped to a wall, but
Try and lay your head on a pillow.
yeah, what you
That
can't
was
lay
a
your
bit
head down.
strange. Yeah.
I suppose that might be something you get used to. There, it might not be a massive psychological issue if it's like getting used to a new mattress.
Yeah, you can't. No, it's strange.
Yeah, but on that you've also got to account for the noise there, because there's onboard equipment, there's fans, exercise equipment, environmental control, life support. That's going on
That must be horrible.
all the time, and you're trying to
Yeah.
sleep through it.
Yeah, it
You
can't be
know
very
what it's
nice.
like in a hospital, probably.
Yeah.
During the night, there's noises.
Well,
going
some
on
people
Yeah.
love
all the
white
time.
noise and some people hate it. I mean, I love white
Yeah.
noise. I'd be quite happy there.
So I presume they put earplugs in, mask on, and try and cover your senses as much as possible, really. Don't know.
Headphones, Valdunican. Something like that.
Yeah.
All night.
Does anybody spoke about how many optimum crew members there might be going on a mission, say to Mars, like 6 or 8?
I've heard of a analog mission that's going on called CHAPIA. Stands for Crew Health and Performance Exploration Analog, which has a crew of 4 simulating a long stay on Mars. And I would assume they've chosen 4 for a reason. You know, you don't want too few of you. Yeah, good game of poker.
Evens it out on a game of Scrabble.
I can tell you the optimal crew amount to go to Proxima Centauri B.
Okay.
It's 4.2 light years away.
Yeah.
So if you take the Apollo 11, that travelled at 40,000 kilometres an hour. So that take about 100,000 years. But then there's a Parker Solar Probe, which goes at 700,000 kilometres an hour. So based on that, if you use that technology now, it takes 6,300 years. So obviously one of the theories is one of these generational ships. So there's a couple of French people who did a study, Frederic Marin and Camille Belufi. And they developed this algorithm called Heritage. And what they did is set up basically 100 scenarios with different crew members. And they used different parameters, obviously the amount of crew members, age, life expectancy, infertility rates, ship capacity, obviously checking on inbreeding limitations. So what they did, they set it as 0 inbreeding, because they don't really want that to happen.
Yeah, that's my rule as well.
Yeah. And also brought in, as an average, each mission was to include some sort of catastrophe, like a plague, collision, hell, whatever, which would wipe out a third of the crew. So what they found by putting it through this algorithm, they did 100 missions, and it worked out if they had a crew of 14 breeding pairs, there's 0 chance of reaching Proxima Centauri. So we tried it with 25 men, 25 women. Got a 50% chance. Now, the chance of success to get to Proxima Centauri B is 98 settlers altogether.
98.
That seems
In
doable.
theory, that's a
that's
lot
doable.
less than I thought.
If you've got technology to get to put on that job anyway, then you should be able to build a system for 98 people.
Obviously, the algorithm brought in that, each parent would have one viable child.
Yeah.
And then just kept repeating that in its algorithm. And that's where it started with 98, but by the time 6,300 years down the line.
If you sent 4 ships with 100 people on, increase your chances.
Yeah.
Cost a lot more, though. And that's a lot
You'd
longer
probably be attracted to somebody on a different ship, really, like they do in villages,
yeah.
Yes.
When you know everybody that you've grown up with, you're not interested in them, but there's a cute chap on that ship over there, or
Start
cute
having
lady.
events in different places. And,
Catch a shuttle over.
Yeah.
Sneak out your window at night.
Speed dating.
Yeah. Oh, that's good. Speed dating.
That journey is a lot
just
longer
get in
than
a
this.
rocket.
This Chapio experiment is for a year. No, sorry, more than that. 378 days. They're literally in a Mars habitat. Well, not really. They're not literally in a Mars habitat. They're literally stuck in a habitat that's pretending to be Mars for all that time. And they have to do tasks and maintenance similar to ones they would actually have to do at a Mars base, including spacewalks and crop growth, exercise, basically everything you would expect. And they even have a 22-minute delay and any communication with anyone outside.
Yeah, that's good.
To help with that psychological terms of this kind of stuff. Now, by the way, they'll reach the 1-year mark on the 20th of June this year. And that would be a good Obscast episode to do on Chapia as a topic for an Obscast episode, actually.
Yeah.
But work like this is what's going to make generation ships hundreds of years in the future possible.
Yeah. It's got to be really carefully thought about because, conversely, if people don't get on and there's arguments, I mean, we've all watched the films, haven't we, really, where there's always a baddie.
Big Brother. Back in the day.
I mean, I've watched Don't Look Up, they could just get there and land there and then get eaten.
Yeah.
By what was it called, a Brontonox or something,
I don't know. Yeah. What was that?
On Don't Look Up.
I've not
There's
seen
like a guy that sends a bunch of generations of ships to this distant planet and land there and probably get eaten.
Is that Leonardo DiCaprio?
Yes.
Yeah, I watched that. Yeah.
And anyone who's in the book club reading the what was it, three-body
problem
series will know the dark forest theory, and that if you do send your generational ships out there, you want to be careful not to alert anyone who's looking for you.
Yes.
You see, that's it. I mean, an alternative to the generational ship is the sleeper ships, where it's suspended animation. I mean, that's going to be a lot easier on resources, power, etc. Obviously,
I think initially it's going to be robots. It's going to be technology that we send out there that can survive tens of thousands of years. So we're a long way off. Really worrying about it too much, I think.
And imagine the muscle atrophy you get from being awake and exercising. Waking up from being asleep for a few hundred years.
Oh, yeah.
You're going to have a crink in your neck that's just not going to go away, and you're not going to be able to lift your arms. Unless they come up with some kind of electrical stimulation, actually.
Yeah, it's just like,
do that for you while you're asleep.
Well, it's not just that, it's the bone deterioration.
Yeah.
I think I mentioned it before. I think weight-bearing bones, I think they lose an average of about 1 to 1.5% of mineral density. And that includes calcium. When that gets excreted, it can lead to risk of developing kidney stones. Oh joy! So I mean, what one has to do, they alleviate that. They prescribe potassium citrate for the kidney stones and biophosphate medication to help stop the actual bone loss. So there's lots of problems, but there's lots of solutions.
They're just the ones we know about. We know about so far, but if they go further and for longer, there's other problems.
And then they find a problem, how they're going to.
Well, this comes under what you were talking about, technological advances.
Yes.
Even medical advances. Because it's true what you said about the advances benefiting us down here now, even the stuff that's going on now, never mind for the generational ships, but the work that's being put into these now has a benefit on Earth from materials, computing power, and even economically.
Oh, yeah.
I heard every dollar spent on the Apollo program is said to have created $5 to $7 in benefit in the following decades.
Wow.
Due to stimulating the economy through the space economy, but also the materials that were invented that improved other products or
Velcro and stuff like that.
Yes, but there were so many businesses being employed to innovate for the sake of the space race, things that wouldn't have been innovated otherwise.
Sort of necessity driving invention, and well, we've only really got to look back the last 20, 30 years, and you just think, crikey, it's incredible how advanced we've become and what we've expected and we take for granted.
Well, they were forced to miniaturise things. And that's why we've got mobile phones.
Yes. Well, when you think what they did with the Hubble telescope, how they sort of, the James Webb, sorry, and the way that they learnt how to fold it up because they were restricted on what they could do, and they had all the little motors and everything, and you just think...
The precision on that is ridiculous. They've had to balance them movers using motors that can move slower than the growth of human hair.
Yeah, it's mind-boggling, isn't it, really?
And even going back to Apollo, the computers before the Apollo mission started were massive, but they needed one about the size of a shoebox.
Yeah,
so they made one.
Yeah, they cut the weight down and everything.
To put it simply. But we've got a long way to go in terms of technology to get to long-term space flight. Anyone, in the book club that we have, it seems that the sci-fi we read, because we read obviously a lot of sci-fi, it seems the only way that we get technology to advance at any decent pace is under threat.
Yes.
From aliens in the books or from other nations in real world past situations. But hopefully we won't need that kind of motivation forever. So, but before we wrap up, I want to ask everyone here, do you think we'll see much progress towards the moon or even Mars in our lifetimes?
Certainly.
Yeah? In terms of colonisation or just short trips?
As far as Mars is concerned, certainly landing there within the next 10 years.
With people?
A colony within the next 20.
In Mars? Oh, wow. That's my timescale, but for the moon.
Well, yeah, I think I agree with you there.
Optimistic.
Yeah, I think from everything that I'm not expert, but the race is definitely on, and
it's not just the race between nations; it's the race between private companies as well.
It is,
that's
what's driving it all.
Yeah, it seems nations are racing for low Earth orbit stations and stuff on the moon, but private companies are racing for better launch capabilities to sell to the nations.
Yes,
low Earth orbit and the moon as well themselves, but they're looking. Maybe for different reasons. They're not looking for military reasons, maybe. They're looking for what can we extract that we can make money out of in the future.
Yes.
Well, I can remember when... I'm old, but I can remember when they landed on the moon. I watched it on the TV. And so we have done that. We've managed it all those years ago, 50-odd years ago. But... I think there's more important things than getting somebody to Mars or again to the moon. It's all about developing technology, and there's nothing wrong with that. It's all getting better and better. But it's about finding life within our solar system. That's the real big scientific, that's what we want to see. It'd be lovely to see not complex life, just life. Yes. If we can find it within the outer solar system, then just imagine, then we can think... If it can survive in those conditions, then it's likely to be all the way through the universe. And 20 years ago, we didn't even know there were any exoplanets. No. Now, we've confirmed there's thousands of them, and we suspect most stars have got them. So we are coming on leaps and bounds. Technology and our knowledge is increasing all the time. I think it's important to keep continuing on the AI and the robots and mechanics and rockets and everything else. We're nowhere near close enough to send people any further than Mars.
I think the importance of finding life is sometimes more important, I think, because I think some people think, if we find life, it's like, we found life. But if we find life in our solar system, like a second Genesis, then it's everywhere. It's everywhere in the universe. We only have one sample now, but if we find two samples that started completely separate from each other in the same solar system, then the odds of it being absolutely everywhere in the universe are just...
Don't rise exponentially, won't it?
Yeah, it's just incredible. Just from finding one more.
And the Goldilocks zone will suddenly expand as well.
Yeah, and I don't think...
It won't be just that, that small zone of what we think is, viable for life. It widens.
Well, I remember learning at primary school that you needed the sun for life, and now I know that you just need an energy input for life, for warmth.
Yeah.
Okay, so if given the choice, after all we've just spoken about and just heard, would any of you go on a long-term moon mission or mission to Mars or anything of that sort?
Personally?
I'd love to have gone.
No.
That's my gut feeling. I would love to have the chance to go into space and maybe go to the moon or something like that. It's easy said.
I'm with you.
If they develop artificial gravity, I'll think about it.
What about you, Kathryn?
I'd love to see what they can see when they're out there, because it shows you looking back on the Earth, and the Earth is so beautiful. And they always say this. The astronauts always say the same. They come back with that. It's so precious. It's so beautiful. It's so unique.
But if someone actually offered you to go,
somebody offered
to the ISS, because I think that's where I'd go. The ISS and the moon.
Yeah, I'd give it a go.
Would you do 6 months?
Would I do 6 months at my stage in life? I probably wouldn't if the children were younger. But yeah, go on then. I'd risk the puffy face.
That's where I'm at now. Yeah. But I think maybe just the ISS. I think I could do a good stint on the ISS. Go see what it's all about. Have a gander back at the Earth. Come home after a few months. I'm not sure about the moon or Mars. The moon, it would depend.
Yeah, depends what it's like when you get there. You can't imagine once this constructs something. I mean, all you can tend to go on is films that we've seen, isn't it? Really?
Yeah. I mean, how long were the Apollo astronauts going there, staying there, and coming back? Was it 3 days there, 3 days back, a couple of days there?
I think it's 2 days there. Went to 40 something hours.
That's a short
break. Do that in a week, can't you? Just have a week off work.
It's not it must be a fascinating place to visit, but it's not a particularly nice place to live on because the dust is so abrasive. It gets everywhere, and if you were inside a building, to get from the outside to the inside, you'd have to be really cleaned to get back into a building. It's going to be a challenge.
Well, thank you very much.
Thank you.
Thank you.
Thank you very much for being here. It's been great. Kathryn, thank you very much for doing the research on this one. Exceptional work.
You're welcome.
We're now going to take a break, and Steve Smith will be back with his lookup section. If you want to read Steve's full and unabridged lookup article, complete with visual guides, brilliant descriptions, target lists, and heaps of helpful tips for your own stargazing activities, then you will need to become a member of MSAS for less than £1 a week, after which you will receive the whole thing free along with a monthly newsletter, Event Horizon, which may as well be its own magazine, because it's chock full of articles, reviews, astrophotography, and much, much more. Steve will be back with you in a few short seconds.
Hello, this is Steve Smith with my monthly Looking Up Obscast. I do the monthly Looking Up articles in the EH to inform members about some of the many seasonal objects that come around each month. Have you ever gone outside on a starry night, got set up and then wondered where to start? I have been there. So I have learnt that it is important to have a list of objects ready for the next observing opportunity. Your list may include galaxies, open star clusters, globular clusters, double stars and nebulae. The planets and our moon do their own thing, so you need to check up what's up there at the time you want to observe. There's always plenty to see if you are aware of what is currently up there. If I have a successful observing session, I usually write an account of the session, listing brief details of what I have seen and any thoughts that occurred to me at the time. It is good to be able to look back on these sessions and share observations with other keen observers. So if you have a good viewing session, why not write it up and email it to the Society's Event Horizon magazine to share with your like-minded fellow members. OK, here we go with this month's Looking Up. From the start of May, true astronomical darkness lasts from around 12 p.m. till 02:10 a.m. So not many hours of full darkness there. Summer is fast approaching, of course, and the weather is warming up. May is a great time of the year for viewing, and the sky is full of amazing sights. So let's make the most of our late spring's dark evenings before those summer light nights creep up on us. So what are this month's highlights? There is, sadly, a lack of planets available to us this month, but the sublime Saturn is back on the scene, making a welcome comeback in the morning sky, though it is residing low in the sky at only 10 degrees above the horizon, so its position doesn't allow for serious viewing. Most of the other planets are somewhere close to the Sun. It is galaxies galore again this month. The seasonally well-placed Plough has several galaxies in it and around it. There are loads of spring galaxies in Virgo and Berenices plus Leo has another dozen or so galaxies worth seeing. Just think, whilst gazing at these galaxies, how many billions of stars are contributing to the faint smudges you are viewing, and how many millions of years those photons have been travelling. If you can stay up later, you can catch the start of the globular cluster season too, including fat globular clusters like M3, M10, M12 and M13 to name a few of the big hitters. Question: have you ever seen M13's propeller? More on this later. Also, nebulae like favourites the Ring Nebula, which is M57, and the Dumbbell Nebula, which is M27, are now in range early mornings. This is one I've never seen, but asteroid Pallas comes to opposition on the 19th of May, reaching +9 magnitude and peaks around 1:35 a.m. to around 60 degrees above the horizon. It has an unusually high orbital inclination of over 38 degrees, taking it far from the ecliptic. Pallas was the second asteroid discovered. The first was Ceres in 1802 by Heinrich Olbers, 1758 to 1840. He was a German astrophysicist. It is the third largest asteroid behind Ceres and Vesta's and is an asteroid belt object. A pair of binoculars or a small scope should enable you to see it. We may also get the chance of spotting some incoming debris from a previous long-ago pass of Halley's Comet in the form of the Eta Aquarids meteor shower, which is at its best on the evening of the 5th of May, when 10 to 30 metres an hour may be seen. These are fast meteors that often leave ionized trails lasting several seconds. Wow, happy hunting. Deep sky on show. As always, last month's items mostly apply. Libra, the scales, is at opposition on the ecliptic this month, and there are a few items of interest to be found within this constellation. NGC 5897 is a loosely scattered faint globular cluster 45,000 light-years away, but it is faint at +8.5 mag and is difficult to see through small instruments. NGC 5792 is the 11th mag spiral galaxy, 84 million light-years away. That's 84 million light-years. Photons have been travelling that long since they hit your eyeball. Amazing. But that lies away in the northwest boundary of Libra. It is seen as nearly edge-on, with a bright nucleus and faint arms, and can be seen in a 10-inch or larger telescope. There are photos of most of these in the EH, just to remind you. NGC 5898 and NGC 5903 are interacting galaxies. 5898 is an E1 elliptical galaxy and has a broadly concentrated halo with no prominent nucleus. Its partner, NGC 5903, is somewhat smaller and lies 6 arc minutes to the east of NGC 5903. It has an extended core with stellar nucleus. Just look into the area to the left or eastwards of Libra in Ophiuchus and Scorpius, you may notice how busy it is with NGC and Messier objects like globular clusters M4, M80 and 107 to name a few of the brightest. And just out of view to the left Also M9, M10, M12, M19 and M62, they're all coming up. And these will be more present next month. These fat globs will be covered in more detail in next month's Looking Up article. But they are available to us this month, though you may have to stay up an hour or two later than normal and wait for them to climb higher in altitude. Elsewhere, let's have a look at the constellation Boötes, lying north of Libra. It offers some real delights, but first to Boötes' brightest star, Arcturus, and a reminder of what it is and how to find it. Arcturus is the Alpha star. It is the fourth brightest star in the night sky and the brightest star in the northern hemisphere. Its name starts with ARC, arc, and if you do arc a line of sight down from the curve of Ursa Major stars Alioth, Mizar and Alkaid, that's a panhandle. If you follow them down, it will lead you directly to the very bright star to the south, and this will be Arcturus. Note, if you arc even further down through star Arcturus and towards the horizon, you will reach Spica in Virgo. Right, and Spica is a very prominent star too. The name Spica is derived from Latin and means Virgo's ear of grain. NGC 5248, also known as Caldwell 45, is a compact 9th magnitude intermediate spiral galaxy about 59 million light years away in the constellation of Boötes. It is a member of the NGC 5248 group of galaxies. Itself is one of Virgo 3 groups strung out to the east of the Virgo supercluster of galaxies. NG 5466 is a Class 12 X11 globular cluster in the constellation of Boötes.
Can I interrupt you there?
You want to know what that classification
I'm going to
is?
show my ignorance here. I'm sorry. What is a Class 12 globular
This is fairly
cluster?
new to me. Class X11 or 12 is quite interesting, really. From 1927 to 1929, Harlow Shapley and Helen Sawyer Hogg began categorising clusters according to the degree of concentration the system has towards the core using this scale. It's a scale of 1 to 12, and this became known as the Shapley-Sawyer concentration class. The system uses a scale of 1 to 12 using Roman numerals for globular clusters according to their concentration. Their most highly concentrated clusters, such as M75, are classed as Class 1. With successively diminishing concentrations ranging to Class 12, such as Palomar 12. The class is sometimes given 1 to 12 rather than using Roman numerals. And just interestingly again, Palomar 12, it's not called Palomar 12 because it's a 12 class, it is 12th out of 14 objects called Palomar. That's all, that's the only relative thing to it. Okay, does that answer your question?
It does, it sure does. Thank you.
Thank you, Kathryn. Okay, just moving further on then. In Canis Venatici, which is well placed at this time of year, there are several items of note. M63 is the striking looking sunflower galaxy. Nearby is M106, one of our brightest galaxies to see, at only plus 8.3 magnitude. Also, NGC 4244 is a spindle-like galaxy that is well worth a look. So there's loads of galaxies out there. In the southeast of Canis Venatici lies M3, which is a globular, and it's a very, very bright one. It's a famous one, shining at magnitude plus 5.9 and occupying 16 minutes of true field of view. It can be picked up in binoculars. Its outer stars can be resolved in a 3 to 4 inch scope at 100 times magnification. M3 looks magnificent in an 8 to 10 inch scope. It is only slightly inferior to the fabulous globular cluster M13. Note, we mentioned M13. The propeller I mentioned earlier regarding M13 in Hercules can be discerned within the nucleus of the globular. Some dimmer areas appear in the shape of a 3-bladed propeller. Once you have seen it, you will find yourself looking for it whenever you take a peek at M13. I do. Let's spend a few moments on M51, the famous Whirlpool Galaxy. It's probably the most famous object in Canis Venatici. See below at the picture that's in the EH. Famously, the Whirlpool spiral arm structure was the first spiral to be seen visually in a galaxy, when in 1845 Lord Rosse discerned it in his 72-inch diameter Newtonian reflector at Birr Castle in Ireland. We now know that M51 consists of a pair of distant interacting galaxies and not just a gaseous nebulosity in our Milky Way. The very pronounced spiral structure of the Whirlpool galaxy is believed to be the result of the close interaction between M51, which is actually NGC 5194, and its companion NGC 5195. The advent of radio astronomy and subsequent radio images of M51 have demonstrated the interaction is real. Now you can see these on through a big scope, and if the conditions are ideal. M51 is easy to find. It's only 3.5 degrees southeast of Alkaid, which is right at the end of the plough's handle. It is the easternmost star at the end of the plough's handle, in fact. M51 is a showpiece if the sky is dark, but it is quite sensitive to light pollution. With overall dimensions of 11 minutes by 7 minutes and a visual magnitude of plus 8.4, M51 is visible in binoculars under dark sky conditions. It has a bright core and a large faint halo. Under very good conditions, suggestions of its spiral arms can be seen with a 4-inch telescope. Low magnification is best for viewing these pair of galaxies. With larger 12-inch telescopes and above, the spiral arms are more visible, separated by dark swells north and southwest of the core. These sights create wow moments that will stay in your thoughts for several days after seeing them. There are many more details about these items and areas in the Event Horizons Looking Up. I also mention what is happening with the planets, and I have listed and charted recommended objects for this time of year too. Again, it would be good to hear from you about any observing sessions you may have had, or we can have a chat about any of this stuff when we are up at the Obs on any wonderful Wednesday evening. So, are you now ready for looking up? Thank you.
Thank you for listening to the Obscast. Before we go, here are your events for May. On Saturday the 18th we have an open day, so if you are not a member, try and get tickets for that. If you are a member, please get in touch with Brendan Schooler if you want to volunteer. On the 22nd of May we have a members only talk presented by John Brown, and on the 28th of May we also have another talk by Paul Money, astronomer and reviews editor for Sky at Night magazine, giving a talk on new images of the universe. Thank you again, and we will see you next time on the Obscast.